Hello everyone, myself Dr. Siddharth Reddy, Associate Professor of Chemistry, Vardhaman College of Engineering, Hyderabad. In this video, I am going to discuss about battery chemistry. First, we should understand what is the meaning of battery. Battery is nothing but it's an electrochemical cell which are connected in the series. Each of cell it consists of two electrodes and one electrolytic solution is called battery. And these are some examples we can take what we are observing in our day-to-day lives. Next, we are going to discuss about requirements of batteries. First one, high capacity, which is small variation of voltage during discharging of the battery. Second one, high energy efficiency. Energy of efficiency nothing but percentage of efficiency is equal to energy released during discharging by energy gained during charging into 100. If we get more percentage of efficiency, we can say that it is a good battery. Suppose let us consider A, B batteries are there. If we calculate for A battery, if the percentage of efficiency is 99%, for B battery if it is 90%, then we can say that A battery is a good battery. Third one, high cycle life is required, which is the meaning of number of charging and discharging cycles before failure. Let us consider R is a reactant is converting into P. This reaction takes place always during the discharging. Again, if you take P will be converted into R, this will be takes place during the charging of the battery here. Now you observe this case, the forward reaction, that is reactant, should be converted into products. Backward reaction, products will be converted into reactants. Now you observe this one, it looks like a cycle. If more number of cycles are present, then we can say that there is a good battery. Last one, long shelf life is required. How much time it will be work, and based on that we can decide that which is a good battery and which is not a good battery. Next one, the classification of the batteries. Generally batteries are classified into three types are there. Based on the working, based on the functioning, they are classified into three types. First one, primary batteries. Second one, secondary batteries. Next, the fuel cells. Primary batteries nothing but cell reactions are reversible, cell reactions are not reversible. The meaning is R should be converted into P. Let us take reactants are converting into products, but the products will not be converted into reactants. That is the meaning of what? Not reversible case. If you take secondary batteries, reactants are converted into products, it's fine. And then again products will be converted into reactants. When the reactants will be converted into the products means during the discharging of the battery here. When the products will be converted into reactant, that is the case happens in case of charging. And if we move to the fuel cells, energy can be withdrawn indefinitely. That is as long as the fuel is maintained. Meaning is if we supply the reactants, then it converts into the products, then energy will be released. Nothing but there is no storage capacity is present in between this, and that is defined as what? Fuel cell. Next one, second difference we are observing, it cannot be recharged as we know that, and it can be recharged, and fuel cells not have a capability to store the energy. Third one, can be used as long as materials are active in their composition. That is the main difference what we are observing in between primary and secondary batteries. Meaning is, let us consider whenever we are buying a phone or anything, let us consider 100 reactants are present. Yes, 100 reactants are active in state. slowly after time process, then what happened? Then 90 reactants are left, 10 reactants are converted. Slowly at the end of the case, here 0 reactants are present. Nothing but the cell is dead. Further, the functioning does not take place. And if we move to the secondary battery, can be used again and again by recharging the battery. Yes, reactants can be converted into the products. Again, what we are observing, products will be converted into the reactants. This case happens continuously, and that is considered as what? Secondary batteries. Cannot be reused, which we can call it as fuel cells. Next, examples, Leclanche cell. This we are also calling it as dry cell, we can call it as. And also, some of the lithium batteries comes under category of primary batteries. Next, examples of secondary batteries, lead acid storage batteries, lithium ion batteries, lithium ion cells comes under category of secondary battery. Yeah, it is an interesting thing here we are observing. Lithium cells comes under primary batteries, lithium ion cell comes under secondary batteries. And next one, we can also consider nickel cadmium battery here. It is another example which we can consider under secondary batteries. Next, fuel cells. Example we can take hydrogen oxygen fuel cell. We can also take another example, methanol oxygen fuel cell. And also we can consider propane oxygen fuel cell. Here in this thing we can understand one thing, that one common thing is present in all the fuel cells, that is oxygen, which acts as an oxidant which will be stored outside of the cell, which is used for the combustion of the reaction here. And these are the differences. Next we will move to the primary batteries. Let us take as we have discussed just now, that is in which the cell reaction is not reversible, right? Or should be converted into the P should not be converted into the reactants. That is called what? Primary battery. And as we discussed, that cell becomes dead. Dead meaning is what? After complete conversion of reactant to the products, the further functioning of the cell does not takes place. That is called primary batteries. And we have taken the examples. Previously we discussed that Leclanche cell, lithium batteries are the examples of primary batteries. Now we'll move to Leclanche cell, which is also called zinc carbon cell, which is also called dry cell we are calling here. As we are discussing, this is called dry cell, right? The dry cell meaning is a cell without fluid component, without liquid, we can consider as what? Dry cell here. If we move to the construction, this is a diagrammatical representation of Leclanche cell, which consists of, as we know that any battery which consists of what? Anode, cathode, electrolytic solution must be present, right? As we know that anode we are taking, if it comes to the construction, anode we are taking zinc act as anode, which carries a negative charge. Next, if we move to the cathode, graphite, which is present, which is placed in the middle portion of this particular battery, which will be act as a cathode here. That is here we are representing zinc anode, carbon is act as a cathode. Next one, and in this electrolytic solution, that electrolytic solution is a very important thing in the functioning of any battery, every battery. Here we are taking that, here in this case the composition which consists of the mixture of ammonium chloride, zinc chloride, manganese dioxide, along with that we are adding the starch. The role of starch is which is used to prevent the leakages in this particular battery, that act as what? Electrolytic solution which we are using in the Leclanche cell. Next, if we move to the cell reactions, nothing but how the working of the battery is taking place. Working case. That working case we can understand based on the reactions, right? Based on the reactions, nothing but what? As we discussed, mainly two electrodes are present. We know that one is anode, and where which reaction takes place here? Oxidation reaction takes place. Oxidation, nothing but what? Loss of electrons. Loss of electrons. Here in this case, zinc is acting as a anode. Let us discuss what are the reactions which takes place at anode. First one, zinc undergoes oxidation, meaning is it loses its electrons and converted into Zn plus 2 electrons are released. This released Zn plus 2 ions combines with ammonium chloride and OH minus ions, gives rise to zinc ammonium chloride is a product. That is ZnNH3 taken 2Cl2 plus H2O. And we have to balance the equation. Zn 2NH4Cl 2OH minus gives rise to Zn NH3 taken 2Cl2 2H2O. And we can write the combined reaction of these two, and whenever we are taking this will be get cancelled, and the net reaction is Zn plus 2NH4Cl plus 2OH minus gives rise to Zn NH3 taken twice Cl2 plus 2H2O plus 2 electrons will be released. As this is a reaction what we observed in case of what? Anode. Next we will move to the cathode. As we taken graphite, right? Graphite is a cathode where what the reaction takes place means here manganese dioxide, right? Manganese dioxide, just now we have discussed that, which is a part of electrolytic solution. It undergo reaction with water, and as we discussed, electrons are released at anode, right? They move toward the cathode, and which is a part of the cathodic reaction and converted into manganese oxyhydroxide plus OH minus ions will be released. As part of balancing the equation, we have to take 2 moles of manganese dioxide combines with 2 moles of H2O, 2 electrons, 2 MnOOH and plus 2 OH minus. And now we are observing electrons are present on the left side, nothing but which is the reduction reaction here. And next we should take that what is the net reaction. Net reaction meaning is the combination of this oxidation reaction and reduction reaction here. The combination of anodic oxidation and reduction reaction, if we take, let us consider here what are the common terms are there. We will cancel the common terms. 2 electrons, 2 electron get cancelled, 2 OH minus, 2 OH minus get cancelled, and 2 H2O, 2 H2O will be cancelled. Then the final reaction what we can written as Zn plus 2 NH4 Cl plus 2 MnO2 gives rise to Zn NH3 taken twice Cl2 plus 2 moles of MnOOH, and also here the interesting thing is the energy should be released. Why? Because this is a primary battery, only discharging reactions are possible. Now whatever the reactions we have discussed all comes under discharging reactions. These are not charging. Why? Because this is a primary battery, that's why here only the discharging reactions are possible here. And this is the net reaction what we are observing in case of Leclanche cell. And if we move to the applications, what are the applications are there here? And we are observing batteries. These are the primary batteries. Generally what we are observing in our day-to-day lives, like calculators what we are using, iPods, digital cameras, we can use in the wristwatches, stopwatches, and also we used in the toys. Next one, the interesting thing is here the pacemakers. Pacemakers meaning is the pacemakers which we can use to control the heart rate. In that case we can use this particular batteries we can use. And these are the general cases what we are observing. We are not just about providing quality education, we believe in all-round development. Thank you.